So hi guys, in this video we will be discussing about an important reagent which is Grignard reagent. Okay, this is a very versatile reagent in our organic chemistry. Okay, let us start by writing its general formula and then we will discuss about this in detail. Okay, so it can be represented by R, Mg, X. So obviously Mg is your magnesium, X can be your halo group. Okay, so if I can write specifically, then I'll write it as CH3 MgCl. Okay, I can write it like that. So this is magnesium and this is your chlorine, that is your halo group. Okay, now let us see the charge separation so that we might understand that how it will attack actually. Okay, so now this CH3 MgX or Cl. So obviously this is your electronegative group. Why? Because in the periodic table, this is your halo group. Okay, so BCNOF in the periodic table, if we go towards right, the electronegativity increases, and halogen is very electronegative. So this is because this is just underneath fluorine, so it is chlorine. Okay, so it is electronegative, so it will obviously attract attract the shared pair electrons toward itself. So this will be near it. So this will be partially electronegative and this will be partially electropositive. So as we know that opposite charges attract, so if this is electropositive, so this will be electronegative. Okay, so this is the charge separation. Now let us study about the stability, that how the reaction is stable, how the reagent is stable. So this is CH3 MgX. So this magnesium, it is actually magnesium exists as Mg2 plus. Okay, why? If you ask why, so because its atomic number is 12. Okay, its electronic configuration you can write as 282. So it can donate 2 electrons to gain stability or to gain octet. So it is 282 and its valency you can say is +2. Okay, now see how it is stabilized. We take this reagent in diethyl ether. This is very important point, that we take this reagent in diethyl ether. Why? Because see, this magnesium is comparatively hard. We take this is in diethyl ether. So this is C2H5. C2H5. Now see, this magnesium is hard. Okay, what do you understand by hard? See, it is a hard acid. Hard acid means it attacks at comparatively hard centers. Okay, we'll discuss about this, but let us see how it is stabilized. Let us see that first. Okay, so if I write the reagent as like CH3 MgX. Okay, or it's better that I'll just write about this metal. Okay, so this is Mg2 plus. As I already said, this is Mg2 plus. So see, this diethyl ether, its molecule has, like if I write it as C2H5, C2H5. So this has lone pair. Lone pair will obviously stabilize this magnesium because magnesium is a hard center. Hard center means it will go to attack on hard center. It is a hard acid. You can say that it is a hard acid. It will be better we say this is a hard acid. So obviously hard acid means positive charge, deficit of electrons. So it will require electrons. So this diethyl ether, it is an ether group. It has lone pair. So it can donate its lone pair via coordinate bond. Similarly, other molecules can also donate its lone pair to magnesium. So by this what will happen, that the charge on magnesium will be decreased. So obviously it will be stabilized. No, see, if you are studying because you want to gain stability in your life. I am teaching because I want to be stable. Similarly, all the atoms, molecules and the charges all want to be stable. So it will be stable only if its charge is lost, because nobody wants to get charged. Okay, because charge is unstable. In terms of chemistry, we say that charge is unstable. So obviously this will donate its lone pair via coordinate bond. It will be stabilized. So that's why we take this Grignard reagent in diethyl ether. Okay, diethyl ether. Now let us discuss that how the Grignard reagent acts. Okay, or how it reacts. If I'll be specific, I'll say that how it reacts. So see, it can act as a nucleophile as well as a base. Okay, it can act as a nucleophile as well as base. So we'll discuss in brief about what is a nucleophile and what is a base. Okay, so that we will have a clear understanding. So as I already said, it can act as a nucleophile and it can also act as a base. So what is base? You might have learned about this in your previous classes, that base is whatever base is like, it has a like base, any base is NaOH. Okay, so what is its tendency? Its tendency is to abstract acidic proton. So what is an acid? I can write this as an acid. This is a very good acid. Okay, this is acetic acid. So if I add any base to it, like NaOH, suppose, so it will, what it will do? It will abstract this acidic proton, and it will become what? It will become CH3CO minus. So here we are not talking about this base. Okay, here we are talking about Grignard reagent as the base. Okay, so if I write the Grignard reagent like CH3MgX, so if I show the charge separation, so this is delta negative, delta positive, delta negative. So this will be the center which will be attacking. Okay, so what it will do, it will abstract the acidic proton from this. So what it will become, you can see, it will be CH3CO O minus. Now, if it is O minus, it will require a positive center. So this is a positive center. So this will attack over here. This will come over here. Okay, plus CH4. How? Because this CH3 was negative and it took this one. Okay, because it is a base. It is acting as a base. So it abstracted the acidic proton. It became CH4. Okay, this is it. Here it is acting as a base. And how it will act as a nucleophile? We'll say this. Here the hard interaction will be justified. Okay. Now suppose that I have taken acetone. This is acetone. Okay. Suppose I have taken acetone. Now see, this is obviously partially electronegative. This is electronegative, so partial negative. This will be partial positive. Okay. Now when this is partial positive, so if I add CH3MgCl to it. Okay. Now you just see that this is electronegative. This is electropositive. This is electronegative. So obviously this center will be attacking over here. Okay, because this is electronegative, partially electronegative. This is electropositive, so opposites attract. Okay, so here the hard interaction is justified. That I said now that magnesium is hard center. So when it is a hard center, it will attack on hard center. So this is what? This has made this carbon hard. Why? Because this is electronegative. So this has made this carbon hard. So now this will attack. This will attack over here. This, see, you have to listen to this very carefully. This has made this carbon hard. Okay. So now this will attack over here. Why this cannot attack? Because this is electropositive, and if this is electropositive, it is comparatively electropositive, so it will require a electronegative center. Okay, so this will attack. Okay, because opposites attract. This magnesium is hard, so it has made this hard. Okay, this is hard, so it has made this hard. So hard will attack. This will attack over here. Now let us see that what will be formed. CH3, C, O minus, CH3. And CH3. Now, if we do hydrolysis of it, so obviously hydrolysis will get H over here. So and H will be attached near this O, because O is minus, so OH, CH3, CH3. So an alcohol. So here we have studied about that how Grignard reagent can act as an acid as well as a base. One very important thing is that you should note this. You should note this, that acid-base reaction is the fastest. Acid-base reaction is the fastest. See, if you are studying organic chemistry, you should always remember this statement, that in any case, if any reaction is there, if you want to approach, you will see that acid-base reaction is the fastest. Okay. Thank you.